In this example, we're being asked to take the limit as x approaches 1 for the natural log of x divided by sine of pi x. All right, so it's a pretty typical limit problem. What we usually do, or what we usually try first, is to take this value and substitute it into the expression, because if we get an answer, if we get like 1/2, then 1/2 is our answer and we're done. There's nothing really left to do. But oftentimes we'll get these things called indeterminate forms, which is what's going to happen here. If you take the natural log of 1, you get 0, and 1 times pi is pi, and sine of pi is also 0. So this is what we call an indeterminate form. Now there's different ways to handle indeterminate forms. Another indeterminate form would be infinity over infinity. I think what's going to be applicable here, since there's not really any algebra you can do to simplify this guy, is to use something called L'Hopital's rule. L'Hopital's rule. And what L'Hopital's rule helps with is exactly this. It helps us take limits that yield indeterminate forms. So it works something like this. It says if this is, we'll call this f and we'll call this g, then it says you can take the limit, right? The limit as x approaches 1 still for f prime over g prime, and it would be the same thing. This limit would equal this limit. And so hopefully by taking derivatives, it'll jar something loose, something will change, and we won't get 0 over 0 like we did, initially. So that's the idea behind L'Hopital's rule. So let's take these derivatives and let's see what we get. Derivative of the numerator would be, let's see, derivative of natural log of x is 1 over x, as we well know. 1 over x. All right, and this will be divided by the derivative for sine of pi x. This will need the chain rule. We would have cosine of pi x times pi, right? From the chain rule, of course. Okay, so let's run through this algebra real quick. You have 1 over 1 in the numerator, and in the denominator, let's see, if x is 1, then 1 times pi is pi. Cosine of pi on the unit circle would be -1, and then -1 times pi would be negative pi. So the negative, it doesn't really matter if you write it in the numerator or denominator, so I'll just write it in the numerator. And so there we go. I have a fixed value. This is a numerical value. That's the limit for this original expression back up here. So even though it looked like it might be undefined to begin with, or the limit might not exist, in fact it does. And so L'Hopital's rule is just so extremely helpful in these types of situations.